Imagine a planet where the sky glows red, or another where oceans of molten lava stretch for miles. Now picture a world with lush forests, rivers, and an atmosphere we could breathe. Exoplanets, planets orbiting other stars, offer all of these possibilities and more. Today, we're on an epic journey beyond our solar system to explore strange, fascinating worlds and ask the biggest question of all: are we alone in the universe? The first exoplanet was discovered in 1992, and since then, we've identified over 5,000 of them. Each discovery pushes the boundaries of our understanding, inspiring us to look deeper and dream bigger. Are there other Earth-like worlds out there, teeming with life, or will we find barren yet equally fascinating landscapes? Join me, Greninja Pokemon 08, as we embark on this cosmic quest. From the methods we use to find these distant worlds to the potential for human colonization, we'll delve into the science and wonder behind exoplanets. Buckle up, because this journey is bound to be as mind-blowing as the vast universe itself. Ready to explore? Let's dive in. First things first, what exactly are exoplanets? They're planets that exist outside our solar system, orbiting stars just like Earth orbits the Sun. Since 1992, we've discovered over 5,000 exoplanets, each as unique as a snowflake. Some are small, rocky worlds like Earth, while others are gas giants like Jupiter or even super-Earths, bigger versions of our home planet. Fun fact: the first exoplanet ever discovered was in 1992, orbiting a pulsar, a rapidly spinning neutron star. Can you imagine the light show there? Pulsars emit beams of radiation that sweep across space like cosmic lighthouses. Each exoplanet tells a story about the conditions in which it formed and evolved. Some have scorching temperatures, while others are permanently frozen. There are planets with atmospheres rich in exotic gases, and those with conditions that could potentially sustain life. Understanding exoplanets also helps us understand our own place in the cosmos. By comparing these distant worlds to Earth, we gain insights into the history and future of our own planet. Are we unique, or is Earth just one of many habitable worlds scattered throughout the galaxy? The discovery of exoplanets has profound implications for our search for extraterrestrial life. Our fascination with exoplanets is more than scientific. It's deeply human. So how do we find these distant worlds? It's not like we can just point a telescope and see them clearly. Planets are tiny compared to their stars, and the star's light often drowns them out. Astronomers use the transit method, measuring dips in a star's brightness as a planet crosses in front of it. This method has led to the discovery of thousands of exoplanets. When a planet passes in front of its star, it causes a slight dimming of the star's light. By observing these dips, astronomers can infer the planet's size and orbit. This method requires precise instruments and careful monitoring. The radial velocity method detects the gravitational influence of a planet on its star. As a planet orbits, it causes the star to wobble slightly. These wobbles can be measured through shifts in the star's spectrum. This technique has been instrumental in finding exoplanets around nearby stars. With advanced telescopes like the James Webb Space Telescope, we've started capturing direct images of exoplanets. Direct imaging allows us to study the planet's atmospheres and surfaces. The quest to find exoplanets is an ongoing journey, one that will continue to captivate and inspire us. Why are exoplanets so important? These distant worlds could hold the key to humanity's future. What if Earth becomes uninhabitable? Exoplanets might be our plan B. Scientists are hunting for the Goldilocks zone. Not too hot, not too cold, where life as we know it could thrive. And guess what? We've already found some promising candidates. The concept of the Goldilocks zone, or habitable zone, is central to our search for life. It's the region around a star where conditions are just right for liquid water to exist on a planet's surface. Water is essential for life as we know it, so finding planets in this zone increases the chances of discovering life. Some exoplanets in the Goldilocks zone have already shown potential, with conditions that might support oceans, rivers, and even breathable atmospheres. Exoplanets also hold the promise of new resources and opportunities for exploration. As we look to the future, the idea of mining asteroids and exoplanets for valuable minerals becomes more plausible. The technological advancements required to explore and utilize these resources could drive innovation and economic growth. Understanding exoplanets can also provide insights into the potential challenges and opportunities of space colonization. By studying the atmospheres, climates, and geologies of these planets, we can learn what it might take to make them habitable for humans. This knowledge is crucial as we consider the long-term survival and expansion of humanity beyond Earth. The search for exoplanets is also a search for our cosmic neighbors. Finding signs of life on other worlds would be one of the most profound discoveries in human history. As we continue to explore exoplanets, we also gain a deeper appreciation for our own planet. The unique conditions that make Earth habitable and the delicate balance of its ecosystems become even more apparent. The study of exoplanets is a testament to human curiosity and the drive to explore the unknown. So where exactly could humans live among the stars? Here are a few exoplanets that might just work. First up is Proxima Centauri b. Orbiting the closest star to our Sun, Proxima Centauri b is in the habitable zone, meaning liquid water could exist. At just 4.2 light-years away, it's one of our top candidates for finding life, or even setting up shop ourselves someday. Proxima Centauri b is particularly intriguing because of its proximity. It offers a tantalizing possibility for future exploration missions. Imagine a spacecraft traveling to this nearby star system, carrying with it the hopes and dreams of humanity. Next, we have Kepler 452b, often called Earth's cousin. Kepler 452b is about 60% larger than Earth and sits in its star's habitable zone. With a similar orbit and possibly rocky surface, this could be our second Earth. The TRAPPIST-1 system is a jackpot. 7 Earth-like planets orbit a red dwarf star, and 3 of them are in the habitable zone. That's 3 chances for life. If we ever establish a colony there, we'd have a whole mini solar system to explore. Colonizing these exoplanets would require overcoming significant challenges. We would need to develop advanced propulsion technologies to reach these distant worlds and create sustainable habitats for long-term survival. The potential for human colonization of exoplanets also raises important ethical and philosophical questions. What responsibilities do we have to preserve and protect these new worlds? Exploring and potentially colonizing exoplanets would also require international collaboration. The scale of these missions would necessitate pooling resources, expertise, and knowledge from around the world. The idea of living on another planet is both exciting and daunting. It challenges us to think about what it means to be human and how we might adapt to new and unfamiliar environments. The search for habitable exoplanets is a journey of discovery and possibility. But here's the million-dollar question. Could there be aliens on these planets? Basic but cool question. What do we mean by life? Aliens with flying saucers or just bacteria? When scientists talk about life on exoplanets, they're usually thinking small, very small. We're searching for microbial life, bacteria and other tiny organisms, because that's the most likely form of life out there. The search for microbial life involves looking for biosignatures, chemical indicators of life processes. These could include specific gases in a planet's atmosphere, such as oxygen or methane, which might be produced by living organisms. Advanced telescopes and spectrometers are being developed to detect these biosignatures from light years away. But hey, who knows? Maybe there's intelligent life on one of these planets looking back at us, wondering the same thing. The possibility of intelligent extraterrestrial civilizations captivates our imagination and drives initiatives like the Search for Extraterrestrial Intelligence, SETI. SETI projects scan the skies for signals that might indicate the presence of advanced alien technologies. Fun fact: in 2017, astronomers detected strange radio signals from Proxima Centauri. While it turned out to be interference, it sparked a lot of what-if questions. The search for aliens also involves exploring the conditions that might support life. This includes studying the atmospheres, climates, and potential water sources on exoplanets. The possibility of extraterrestrial life challenges us to rethink our definitions and assumptions about life. The universe is vast and full of possibilities. Let's take a quick tour of some of the most bizarre exoplanets discovered so far. First up, we have 55 Cancri e, also known as the Diamond Planet. This planet is thought to be made largely of diamond. Imagine mining there. Talk about bling. Next, we have HD 189733b, known as the Glass Rain Planet. On this exoplanet, winds blow at 5,400 miles per hour, and it rains glass sideways. Kepler 16b, the real-life Tatooine, orbits 2 stars, making it a real-life version of Luke Skywalker's home planet in Star Wars. Another fascinating exoplanet is WASP-12b, which is so close to its star that it's being pulled apart. Then there's GJ-1214b, a water world that might be covered in a thick layer of water or ice. Kelt 9b is another standout, known as the hottest exoplanet. Let's not forget about PSRB 1620-26b, often referred to as the Methuselah planet because it's around 12.7 billion years old, almost as old as the universe itself. Lastly, we have the planet HD 209458b, also known as Osiris, which is slowly evaporating.